Dear learners, welcome back to NPTEL online certification course on novel drug delivery systems. I am Dr. Satish Devanapelli, Department of Pharmaceutical Sciences Technology, Institute of Chemical Technology, Mumbai. So, in our previous lectures, we have seen the various nanocarrier systems in the novel drug delivery systems. So, we have extensively discussed on the polymer based nanocarrier systems. In that we have discussed various polymeric nanosystems, polymeric nanoparticles, and also we have seen what are the polymeric micelles, we have seen what are the dendrimers, and also we have seen some other polymer based systems, and we have seen the various formulation techniques. And after that we started with the lipid based nanocarrier systems. In that, in the second segment, we have seen what are the lipid based nanoformulations, and in that we have discussed on the liposomes, and we have seen various preparation techniques of the liposomes. After that, we have seen what are the solid lipid nanoparticles, and also we have seen the difference between SLN and the nanostructured lipid carriers. And after that, we have started with the vesicular drug delivery systems. In that, we have discussed various vesicular systems. So, we started in that the with the ethosomes, and also we have seen what are the transferasomes, and we have seen the bilosomes and virosomes and other various types of the vesicular systems. So far we have completed 3 different types of the nanocarrier systems. So, today we are going to see on the inorganic based nanocarrier systems. If you remember, in my previous lectures, we have discussed, we classified these nanocarriers into 2 segments, that is organic and inorganic nanocarrier systems. So far we have completed with the organic nanocarrier systems. Now we are going to discuss on the inorganic nanocarrier systems. So, with this introduction, we will start the today's session. So, these are today's my contents. We are going to discuss on the what are the inorganic nanoparticles. We are going to see the various examples, and also we will see the properties of the inorganic nanoparticles, and we will see 3 different examples, which are gold nanoparticles, silver nanoparticles, and iron nanoparticles. Then in the last, we will conclude our session with the FDA approved inorganic nanoparticles. So, yes, we know that inorganic nanoparticles, yes, which are non-carbon based materials and which may contains metals, metal oxides and ceramics, which will give the higher stability compared with the organic particles, nothing but liposomes and other lipid based particles and other polymer based carrier systems. Yes, we know that whenever you use some type of lipid based formulations, which may leads to the aggregation because of thermal stress and other chemical stress, which leads to the aggregation. But whereas metals, they are the high in the stability, and also with they will provide a unique properties that we are going to discuss in upcoming slides. Not only that, which are very resistant to the chemicals during the preparation as well as in the body microenvironment, which can resist to the all type of the acidic and the basic conditions in the body. So, now here we can see this picture, you will understand various types of the inorganic nanoparticles. So, you can see the quantum dots and the silver nanoparticles, gold nanoparticles, iron oxide, mesoporous silica, and then carbon nanotubes. So, these are various inorganic nanostructures which we can use in various platforms. So, now inorganic nanoparticles can be functionalized for conjugation with the biomolecules, polymers, drugs, enabling application in biotechnology, drug delivery, and then magnetic separation as well as diagnostic imaging. So, these are the various applications. Yes, definitely when you compare with the organic based systems like polymeric and other lipid based carriers, yes, inorganic nanoparticles shows the toxicity because of the presence of the various metal groups and other metal oxide groups and the various functionalities that leads to the toxicity. These materials induces the oxidative stress in the cells that leads to the damage of the cells. So, to avoid that, so we need to conjugate or we need to modify the surface of the particles, magnetic nanoparticles with the various types of the biomolecules. Now, you can see here, you can also use polyethylene glycol to modify the surface of the nanocarriers, especially in inorganic nanocarrier systems. And also you can use various types of the biological molecules and the drugs, and also you can use various types of the carbohydrate based polymers and carbohydrate molecules. With that, you can reduce the toxicity as well as you can also enhance the targeting in the cells, and also you can enhance the circulation time, that is nothing but half life of the molecule by using these biomolecules, polymers. Yes, drugs also you can use for the drug delivery application. So, surface functionalized nanoparticle can act as a targeted drug carriers when modified with the antibodies. Yes, these are active targeting systems, even also by using of the modifying with the surface with the polymers and other type of the biological molecules, it also involve in the various targeting system, that is also passive targeting systems. So, these are the some of the advantages compared with the organic nanoparticles. So, here we will see the what are the unique properties of the inorganic nanoparticles. Inorganic nanoparticles exhibit a unique magnetic properties and also which may provide the electrical properties and as well as which will give the optical properties. So, this only possible with the inorganic nanoparticles, which is not possible with the organic nanocarriers. So, with this, so lot of research is going and people are using in the various drug delivery as well as the biomedical imaging application, because if when you want to target into the particular site and to see the as an image, so your carrier should be considered or that should be work as a contrasting agents. So, when you have it such unique magnetic and electrical and optical properties, so with such systems you can use it as a biomedical application, whereas same property you will not see with their bulk counterparts. Nothing but if you take a silver ion and that will not show such properties. When it convert into the silver particles, silver nanoparticles, after the reduction, then this will show such type of the magnetic and electrical and optical properties. Of course, with the silver it is not possible, whereas iron oxide nanoparticle will give the magnetic properties. The properties of inorganic nanoparticles can be tailored by the controlling size, the structure and the shape, the surface and the domain interaction. We have already discussed in our previous slides. So, we can also modify the surface by using these are the various systems. You can see here there are so many molecule list is there. With that you can modify the surface of the nano systems. So, here is a one example, that is a gold nanoparticles. So, by using this you can modify the surface coating. Yes, as well as you can also functionalize with the different positive charge, negative charge, neutral charges of the molecules. You can also use polyethylene glycol. So, these are already we have discussed. Now, the interesting point is that with this system, with this inorganic system, you can provide the particle size from 1 nanometer to the 1000 nanometer. So, you can also get the particle size in the range from 1 to 100, 1 to 100 is possible, and 100 to 200 is possible, and 200 to 300 is possible. Even if you required, you can also get the below 10 nanometer. So, that is the beauty of the inorganic nanoparticles. Compared with the organic nanoparticle systems, the inorganic nanoparticle, especially the silver, gold and the iron nanoparticles, are the size is very less compared with the organic nanoparticles. Yes, not only that, by controlling the various factors during the synthesis, you can also get different shapes of the particle. Yes, nowadays there are the lot of scope in the non-spherical particles, even in the polymer system also, which is possible, but the chances of the getting various types of the shapes possible with the only with the inorganic nanoparticles. Now, here you can see the nano shells, and also you can see the nano cage, nano stars, and you can see the nano rods, which will mimic similar to the bacteria, right. So, these are the non-spherical type of carrier systems also has a lot of advantages in the biomedical and drug delivery applications. Yes, we know familiar with the nanospheres and the nano shells, but in inorganic you can have various types of the and various sizes of the particles. So, now here is a one more example, the gold nanoparticle. So, here you can see the gold nanoparticle having following advantages. So, here you can see the physical and chemical properties which will enhance the efficiency of the drugs, drug loading and the biocompatibility is possible. Yes, you can also target on the cancer cells by modifying the your surface functions. That will also enhances with the blood flow, non-toxic to the normal cells. While using the targeting, you can also reduce the toxicity in normal cells. Here also this already we have discussed, you can have the particles from the 1 to 100 nanometer. If you require, you can go higher range also, and you can see the various shapes and you can see the various surface charges. So, that is a possibility with the gold nanoparticles. And now you can see the various applications of the gold nanoparticles. You can use in the drug delivery, you can encapsulate your drug, whether it is anti-cancer drug or any type of drug. If you want to reach a target site, you must be encapsulated during the preparation of the gold nanoparticles. And you can also use for the imaging agent, but you should have such properties which can work as a contrasting imaging agent. And also this is one of the upcoming, and nowadays there are so many the market products are available with the photothermal therapy. So, here after the in presence of light, your material will sensitize and that will give the response. Radiotherapy also possible by using the radioligands, and during the radiation your molecule, your nanocarrier will get stimulated and then it will show the response. Targeting, these are already we have discussed, it may be active targeting and passive targeting, and also you can use various types of the nanosystems that will work as a catalyst in during the enzymatical reactions. And now here the another example is silver nanoparticles. We all know silver nanoparticle will works as a the antibacterial activity. So here see this silver nanoparticles offer an advantages such as diverse synthesis methods. Now we will see with these two examples, and also it will show the optical properties which can also used in the biosensors, and also which you can use in the wound healing and other drug delivery applications in the medicine. So here how silver nanoparticle will forms. So here we can see the synthesis of silver nanoparticles. So here you need to take silver chloride, or you can use silver nitrate, right. With that we need to treat with the sodium borohydrate, which is works as a reducing agent. So that reducing agent will reduce the silver ions into the silver nanoparticles, but which is not stable, that will undergo the aggregation. So here we need to use various types of the stabilizers which will control the aggregation of the silver nanoparticles. So first step is reduction and then the stabilization of the silver nanoparticles. Now this is the conventional and the general technique we use for the synthesis of silver nanoparticle. So nowadays we know the various green synthesis techniques are coming with for the production of the silver nanoparticles. Yes, they have their own advantages, and which is called as biogenic silver nanoparticles. Nothing but, so these constituents from the microorganism and from the plants and the enzymes and with the irradiation, which will reduce the silver into the silver nanoparticle. So that extract isolated molecules that need to be reduced with the silver ions. So yes, definitely that will remove the all type of use of solvents, which also consider as a green synthesis, and yes, definitely also that will reduce the energy during the synthesis of the silver nanoparticles. So to know more, this is our review paper. This is an open access paper. If you want to read, you can go through this article and you will find the various related information on the synthesis of the nanoparticles. Now one mechanism I want to highlight here, because we know various types of the silver grades or silver salts, we will use it as a antimicrobial applications. So that is my concern to see the antimicrobial mechanism of silver nanoparticles. Now here which we have highlighted in this paper, you can go and read the various mechanisms. So here the first mechanism is inhibition of the DNA synthesis. So it will stop the synthesis of DNA, that is one mechanism, and the another mechanism inhibition of the mRNA synthesis and cell membrane breakage, inhibition of the protein synthesis, inhibition of cell wall synthesis, mitochondrial damage, and the inhibition of the electron transport chain. This all leads to the destruction of the virus or any type of microorganism. So that is the fundamental concept involved in the silver nanoparticles. So now the another carrier, that is magnetic iron oxide nanoparticles. The name itself will understood that which are the magnetic properties. Now yes, which are the metal particles and also metal oxide particles, so which will used in the various biomedical fields, because of they have the contrast properties, so which can be used as in the MRI and the tissue repairs and the biomedical imaging, in the immunoassay, drug delivery and the cancer hypothermia and protein separation and the purifications. Because of this magnetic property, after the treatment, after the reaction, once you put in a magnet, your iron oxide particle will separate out the required protein or other DNA molecules from the solutions. Okay. So, with this, so the iron oxide nanoparticles have various biomedical applications. Now, the one more important point that which can also the most of the iron oxide or other inorganic nanoparticles which we can use it as a theranostic applications, nothing but these are the dual agents. So, it works as a combination therapy. We will combine here the drug delivery application as well as imaging application together in a one system is it called as a theranosis or theragnostic applications. So, here especially we can use for the cancer therapy and diagnosis. In one system we can use it for imaging and the therapeutical application. So, now you can see here the iron oxide nanoparticle similar to other carrier system, the surface can be modified with the various molecules. You can target with the ligands, you can control the release, you can use various fluorescent molecules. Yes, by modifying the surface you can enhance the biocompatibility. So, now this is the one FDA approved inorganic nanoparticles. So, for more information you can go and visit the article. So, here these are the various iron oxide based nanosystems. The first one is which is approved in 2009 for the treatment of the anemia. So, ferraheme for iron deficiency. So, this is the intravenous iron oxide nano formulations. So, the related information which is given here and what is the particle size and coating. Yes, as we discussed, surface modification very important. See, most of the nanocarrier systems are functionalized with the various molecules, and these are the applications, these are the brand names, these are the generic name. So, similarly, these are the two molecules which can also used as a MRI contrasting agents, and the nanotherm for the cancer treatment, and another one is lumirem is used for the oral gastrointestinal tract imaging agent. So, with this we will understand that there is a lot of scope in the inorganic nanoparticles. So, with this we will conclude. So, today we have discussed on the various types of the inorganic nanoparticle systems. We have seen the properties and also we have seen the silver nanoparticles, iron oxide, gold nanoparticles. So, in our upcoming class we are going to see the various types of the other novel drug delivery systems. Thank you so much.